Hello everyone, my name is Dan the Tutor. So last time we met, we talked about what the limit definition of derivative is and how we can use limits to find the derivative of any function. I know that was kind of out there at the time, so now I want to kind of just hone in our skills with some example problems and really understand what that function means. So again, the limit definition of derivative, that function looks like this. Limit as h approaches 0 of f of x plus h minus f of x all over h. And it comes from the fact that we are choosing 2 points. This comes from the slope formula. This is just saying m equals y2 minus y1 over x2 minus x1. That's where it comes from, if you remember. And what we're doing is instead of using y2 minus y1, x2 minus x1, we're essentially picking the same point, like y2 and y1, x2 and x1. We want those points to be touching each other, but they're not touching, they're infinitesimally close to each other, and the way we represent that is with limit notation. So, moving on. Let's do some example problems. What's the slope of negative 3x plus 4 at x equals 1? Okay? What's the slope of negative 3x plus 4 at x equals 1? By the way, we already know just by looking at this function, this is going to be a linear line, right? Like the slope is the same everywhere, and we know the answer should be negative 3. Here's how we would do it using the limit definition of derivative. We would say, first we say f of x is equal to negative 3x plus 4. Then we say f of x plus h. Remember, we're just replacing, wherever we see x, we're replacing it with x plus h. So that's going to look like negative 3 quantity x plus h plus 4. We can distribute the negative 3, and we would get negative 3x minus 3h plus 4. That's good. And now we can already plug it in to our formula. Limit as h approaches 0 of f of x plus h minus f of x all over h. Now remember, f of x plus h is that thing we just found. So that's going to be negative 3x minus 3h plus 4, that quantity, minus f of x, and f of x is the quantity negative 3x plus 4. That is all going to be divided by h. And so now the next step, we need to simplify a little bit. So we get the limit as h approaches 0 of, in the numerator I have negative 3x minus 3h plus 4, and now the next term plus 3x minus 4. So I'm just distributing out that negative sign there. And then the denominator, I just have h. Okay, so let's see what happens. First of all, the 4's cancel, and the negative 3x and the 3x cancel. And all we're left with is limit as h approaches 0 of negative 3h over h. Now the h's cancel, and we don't even need to plug in anything for h. We're just going to get a limit of negative 3. And so again, that's the slope everywhere because it's a linear function. The slope is going to be negative 3 everywhere for this function, including that point x equals 1 that was asked about in the question. So there's our answer, negative 3. That's how we do it using the limit definition of derivative. Now let's look at another example. Let's say now f of x is equal to negative x squared plus 1, and I want to find this slope at the point x equals 2. Okay, so here's how we would do it. First of all, we have f of x, it's negative x squared plus 1. What's f of x plus h equal to? Remember, we're plugging in x plus h wherever we see x, so it's going to be negative quantity x plus h squared plus 1. We're going to have to first FOIL, or square that term, leave the negative outside, we'll deal with that next. Just foiling this, we get x squared plus 2xh plus h squared, and then plus 1. And so that's going to become then negative x squared minus 2xh minus h squared, still plus 1, after you distribute the negative sign. So now we have everything we need to say limit as h approaches 0 of f of x plus h minus f of x divided by h. And so what that's going to become is limit as h approaches 0 of f of x plus h was negative x squared minus 2xh minus h squared plus 1 minus the quantity, whatever f of x was, which we said was negative x squared plus 1. Negative x squared plus 1. We're going to have to distribute that, and then we get all over h. Just for the sake of not rewriting the entire thing, I'll just distribute this now. So we get negative times negative, that's going to become plus x squared. And when we distribute the negative to the 1, that becomes a negative. And so there we go. That's how it would simplify to. And the reason why this works out so nicely is because now this x squared cancels with that x squared, and this plus 1 cancels with that minus 1. And then what we are left with is the limit as h approaches 0 of negative 2xh minus h squared over h. And remember, we can't plug in h just yet. So what we have to do instead is factor and cancel. And we see we can pull out an h in the numerator. So limit as h approaches 0 of, I'll plug in h, we are left with negative 2x minus h all over h. H's cancel. And now what I'm left with is the limit as h approaches 0 of negative 2x minus h. At this point, I can do direct substitution. I can plug in 0 for h. And what I would get is negative 2x minus 0, which is negative 2x. And remember, this is the slope for any point x. If I plug in x, I get the slope at that point. And in the question, I wanted to find the slope at the point x equals 2. So all I need to do is plug in 2 for x, and I have the slope. So slope at x equals 2 is going to be negative 2 times positive 2, which is just negative 4. And there's my slope. I have now found the slope for my function negative x squared plus 1 at the point x equals 2. And by the way, whenever we think of negative slopes, it means it's pointing downwards. So at that point, it's sloping downwards. And that's going to do it. Those are some good examples of when we would use, or how we would use, the limit definition of derivative to find slopes. And yeah, that's pretty much it. That's everything you need to know about limits. We're going to move on to derivatives next time, and I'll see you there. So, bye.